The inner planets, also known as the terrestrial planets, are the 4 planets closest to the Sun in our solar system. These planets are Mercury, Venus, Earth, and Mars. The inner planets are called terrestrial because they are made up of solid, rocky surfaces, in contrast to the outer planets, which are primarily composed of gas and ice. The inner planets are all relatively small compared to the outer planets. They also have relatively low densities, and their atmospheres are much thinner than those of the outer planets. All 4 of the inner planets have been explored by spacecraft, and they are of great interest because they provide valuable information about the early history of the solar system and the conditions that may have been necessary for the emergence of life. Mercury is the smallest and innermost planet in the solar system. It is a rocky, terrestrial planet that is similar in size and composition to Earth's moon. Mercury is the closest planet to the Sun, and it has a very thin atmosphere made up of traces of gases such as sodium and helium. One of the most striking features of Mercury is its extremely high surface temperature. Because it is so close to the Sun, the planet's surface is exposed to intense solar radiation, and temperatures can reach up to 371 degrees Celsius during the day. At night, however, temperatures on Mercury can drop to as low as -173 degrees Celsius, making it one of the most extreme environments in the solar system. Mercury's surface is heavily cratered, and it is thought to be very old, possibly billions of years old. The planet has no moons or rings, and it has a very weak magnetic field. It is also subject to intense meteorite bombardment. It was first visited by NASA's Mariner 10 spacecraft in the 1970s, and more recently by the Messenger spacecraft, which orbited the planet for several years before crashing into the surface in 2015. The Mariner 10 mission was the first to conduct a close flyby of Mercury, providing the first detailed images of the planet's surface. These images revealed a heavily cratered landscape, with numerous impact craters from meteorite strikes. The mission also confirmed the existence of a magnetic field on Mercury, which is weaker than Earth's but is still strong enough to deflect charged particles from the Sun. The Messenger spacecraft, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, was the first spacecraft to orbit Mercury. It arrived at the planet in 2011 and spent 4 years gathering data and conducting scientific experiments. The spacecraft was equipped with a variety of instruments, including a camera, spectrometer, and magnetometer. One of the main achievements of the Messenger mission was the confirmation of the presence of water ice on Mercury. This was a surprising discovery, as the extreme temperatures on the planet's surface would normally make it difficult for water to exist in liquid form. However, images from the spacecraft showed bright, reflective spots on the surface of the planet, which were later determined to be water ice. This ice is thought to be located in permanently shadowed craters near the poles of the planet, where it is protected from the intense solar radiation. The MESSENGER mission also provided valuable insights into the geology and geochemistry of Mercury. It found that the planet's surface is rich in chemical elements such as potassium, sodium, and sulfur, and that there are signs of volcanic activity on the planet. This suggests that Mercury may have once had a more active and dynamic geology, with volcanoes and tectonic activity shaping its surface. In addition to these scientific discoveries, the MESSENGER mission also achieved a number of engineering milestones. It was the first spacecraft to use a solar electric propulsion system, which allowed it to enter into orbit. It was also the first spacecraft to use the gravity of other planets, in this case, Venus, to adjust its trajectory and enter into orbit around Mercury. Venus is the second planet from the Sun in our solar system. It is the hottest planet in the solar system, with an average surface temperature of about 462 degrees Celsius. Venus is sometimes called the Earth's sister planet because it is similar in size, mass, and composition to Earth. Venus is a terrestrial planet, meaning that it has a solid, rocky surface. It is covered in thick clouds of sulfuric acid, which make it impossible to see the surface from space. Venus has a very thick atmosphere, which is composed primarily of carbon dioxide. This atmosphere traps heat from the Sun, resulting in the extreme surface temperatures on the planet. The atmospheric pressure on Venus is also much higher than on Earth, and it would be crushingly dangerous for humans to be on the surface of the planet. The surface of Venus is heavily cratered, indicating that it is very old, possibly billions of years old. It is also covered in volcanoes, which are thought to be the source of the thick, toxic atmosphere on the planet. Venus also has no moons or rings. Venus is of great interest because of its similarity to Earth, and because it provides a glimpse into the potential future of our own planet. Venus and Earth are similar in size and mass, and they are also the only two planets in the solar system with a denser atmosphere than the Sun. However, Venus and Earth have taken very different paths over the course of their history. Venus is much hotter than Earth, and it has a much thicker atmosphere. This is thought to be due to the fact that Venus is closer to the Sun than Earth, and it has been subject to intense solar radiation over the course of its history. Venus is also of interest because it provides a glimpse into the potential future of our own planet. If Earth were to experience a similar amount of solar radiation as Venus, it is likely that our planet would also become much hotter and more inhospitable to life. This makes Venus a valuable case study for scientists who are studying the effects of climate change on Earth. Several spacecraft have been sent to study Venus, including NASA's Mariner 10 and Magellan missions, and the European Space Agency's Venus Express mission. These missions have provided valuable information about the atmosphere, surface, and geology of Venus. Future missions to Venus are planned, including NASA's Veritas and Da Vinci Plus missions, which are aimed at studying the planet's surface and atmosphere in greater detail. There are several reasons why it is difficult to land on Venus. One of the main reasons is the extreme temperature on the planet's surface. This makes it difficult for spacecraft to operate on the surface of the planet, as their instruments and materials would be damaged by the extreme heat. Another reason why it is difficult to land on Venus is the planet's atmosphere. Venus has a very thick atmosphere, which is composed primarily of carbon dioxide. This atmosphere is much denser than the Earth's, and it would be crushingly dangerous for humans to be on the surface of the planet. In addition, the thick clouds of sulfuric acid that cover the planet would make it difficult for any spacecraft to see the surface and navigate safely. Finally, Venus has a strong gravitational field, which makes it difficult for spacecraft to enter into orbit around the planet and to land on the surface. This requires precise calculations, which can be challenging for spacecraft designers and mission controllers. Overall, these factors make Venus a challenging target for spacecraft, and it has only been visited by a handful of missions. These missions have provided valuable information about the planet, but they have all been short-lived, as the extreme conditions on Venus make it difficult for spacecraft to operate for extended periods of time. There is no evidence of current life on Venus. The planet's surface is inhospitable to known forms of life due to its extreme temperatures and the crushing atmospheric pressure. In addition, the thick clouds of sulfuric acid that cover the planet would make it difficult for any life forms to survive on the surface. However, some have suggested that Venus may have once been more hospitable to life. In the past, the planet's surface temperatures may have been cooler, and it may have had liquid water on its surface. This could have provided conditions that were suitable for the emergence of microbial life. In addition, some have suggested that life on Venus could potentially exist in the planet's atmosphere. The upper layers of Venus' atmosphere are cooler and less hostile than the surface, and it is possible that microbial life could exist there. Overall, however, the evidence for life on Venus is very limited. It is possible that life may have once existed on the planet, but it is unlikely that it still exists there today. Future missions to Venus may provide more. Venus is a fascinating and intriguing planet. Its similarity to Earth and its extreme environment make it an important subject of study. Understanding the conditions on Venus can provide valuable insights into the early history of our own planet, as well as the potential future of Earth. Mars is a fascinating planet that has long captivated the imagination of people on Earth. For centuries, humans have gazed up at the red planet and wondered what secrets it might hold. In recent years, thanks to advanced technology and space exploration, we have been able to learn more about Mars than ever before. Mars is the fourth planet from the Sun and is often referred to as the red planet due to its reddish appearance. It is the second smallest planet in the solar system, after Mercury. It's home to the highest mountain in the solar system, Olympus Mons. Olympus Mons is also the largest volcano in the solar system. It is about 3 times taller than Mount Everest, which is the highest mountain on Earth. Olympus Mons is a shield volcano, which is a type of volcano that is shaped like a broad, gently sloping cone. It is thought to have been formed by the slow release of lava from a single vent over a long period of time. The volcano is surrounded by a wide, flat plain, which is thought to be the result of lava flows that spread out from the volcano and solidified. Mars has the largest dust storms in the solar system, which can engulf the entire planet and last for months. Dust storms are a common occurrence on the planet Mars. They can occur at any time of the year, but they are most common during the planet's summer months. Dust storms on Mars can be very large, sometimes covering the entire planet and lasting for several weeks. These storms are caused by strong winds that whip up fine particles of dust from the Martian surface and carry them high into the planet's atmosphere. The dust can block out sunlight, making it difficult for solar-powered spacecraft to generate electricity. Dust storms on Mars can also be a hazard for any spacecraft that are operating on or near the planet's surface, as they can cause debris to be kicked up into the air, potentially damaging the spacecraft. Mars has 2 small moons. Phobos is one of the 2 moons of Mars. It is the innermost of Mars' 2 moons and is the smaller of the 2. Phobos is irregularly shaped and is thought to be a captured asteroid. It is also thought to be slowly falling apart, with debris from its surface regularly breaking off and falling to the surface of Mars. Phobos orbits very close to the surface of Mars, and it is so close that it actually appears to rise in the west and set in the east, just like the Sun and the stars do on Earth. Deimos is the outer of Mars' 2 moons. It is smaller than Phobos, the inner moon, and is also irregularly shaped. Deimos is thought to be a captured asteroid, like Phobos. Unlike Phobos, however, Deimos has a more circular orbit and is farther from the surface of Mars. Deimos is of interest because it provides valuable information about the history and evolution of the Martian system. It is also a potential destination for future space missions. The atmosphere on Mars is thin and is primarily made up of carbon dioxide, with small amounts of nitrogen and argon. The atmospheric pressure on Mars is much lower than on Earth, and it is not capable of supporting liquid water on the surface. This is one of the reasons why there is no evidence of life on Mars. The atmosphere on Mars is also subject to strong winds, which can whip up dust storms that can cover the entire planet. These dust storms can be a hazard for any spacecraft operating on or near the surface of Mars. The atmosphere on Mars is thought to have been formed as a result of volcanic activity on the planet. The gases released by the volcanoes would have gradually accumulated in the planet's atmosphere, creating the thin atmosphere that we see today. Over time, the atmosphere on Mars has been slowly lost to space due to a combination of factors such as the planet's weak magnetic field and its proximity to the Sun. This has resulted in the thin atmosphere that we see on Mars today. The surface of Mars is home to many interesting features, including volcanoes, canyons, and dry river beds. There is evidence that there were rivers on Mars in the past. This evidence comes from the presence of valleys on the Martian surface that appear to have been formed by flowing water. In addition, images from spacecraft have shown what appear to be dried river beds on the Martian surface. However, it is unclear whether these rivers were similar to the rivers on Earth. The Martian atmosphere is very thin, and it is not capable of supporting liquid water on the surface for long periods of time. This means that any rivers on Mars would have likely been short-lived and would have dried up relatively quickly. There are several large canyons on the planet Mars. The most famous of these is Valles Marineris, which is one of the largest canyons in the solar system. Valles Marineris is thought to have been formed by the movement of the Martian crust, as well as by the erosion of the planet's surface by wind and water. Mars is known to have water on its surface in the form of ice and frozen vapor in the atmosphere. The poles of Mars are the northern and southernmost points on the planet. The Martian poles are covered in ice, which is thought to be mostly water ice. The northern polar cap is much larger than the southern polar cap, and it is also more varied in its composition. In addition to water ice, the northern polar cap also contains significant amounts of carbon dioxide ice. The poles of Mars are of interest to scientists because they provide important clues about the climate and geology of the planet. The ice at the poles may also be a potential source of water for future human exploration of Mars. NASA's Curiosity rover is currently exploring the surface of Mars and has made many important discoveries about the planet. The Curiosity rover is a car-sized robotic rover that was launched by NASA in 2011. It is part of NASA's Mars Science Laboratory mission and was designed to explore the Gale crater on Mars and to assess whether the planet was ever capable of supporting microbial life. The Curiosity rover is equipped with a variety of scientific instruments, including a camera, a spectrometer, and a weather station. Since landing on Mars in 2012, the Curiosity rover has made several important discoveries, including evidence of past water on the Martian surface and the detection of organic molecules. The rover is still in operation and continues to send back valuable data to Earth. There are plans for future human missions to Mars, with the goal of establishing permanent settlements on the planet. As the years go on, we discover more fascinating things about Mars. Every day we learn more of its secrets.